Hello everyone. Today's video is all about the distance and midpoint formulas. This is definitely going to be a two-part video. So this is part number one, we'll call it. It's going to be all about the distance formula. Tune in later for part two's video on the midpoint formula. So let's take a look at the segment that's down below here. We see a segment AB. How could you find the length of that segment? So we're looking at the segment right now on a number line. So the easiest way to find the length of segment AB is to figure out what's the difference in the distances between -6 and +2. From back in elementary school, you guys could do the bunny hop, right, across the number line. 1, 2, 3, 4, 5, 6, 7, 8. To figure out that the length of AB is 8 units, right? But I think we've all progressed a little bit from the bunny hop. So let's try to do this a little bit more algebraically. We want to know the difference in the distances. Well, let's take a look at the differences first. The difference between -6 and 2, right? If we subtract those together, we get -8. But does it make sense for distance to be negative? Are you going to tell somebody, oh yeah, I'll meet you over at the mall. It's like -8 miles away from my house. Nobody says stuff like that. That doesn't make sense. So we have to look at the positive equivalent of it. So in our formula here, we're really just going to be looking at the absolute value of those differences. So if we throw some absolute value bars around our difference, then that means we're really looking at the positive version. So we get the same answer as we did when we did the bunny hop. So in order to find the length of a segment on a number line, you can take the absolute value of the difference between the two endpoints. Let's progress a little further. Let's take a look at now a similar example, but we're going to throw it on a coordinate plane. So instead of just having one dimension now, just going left to right, so to speak, we now have to look at a segment that's on the x-axis and then another segment that's going in the second direction along the y-axis. So if we find the length of A to C, so let's take a look. We can always use our bunny hop to check, but let's take a look at the math now. A is at -3. And C is at +4. So we want the difference in the distances, and then we know we need the absolute value of that. So -3 minus 4 is -7. The absolute value of 7 is 7. So we can say the length of segment AC is 7 units. Let's do the same concept for BD. So we know, and it doesn't matter which one that you start with. So let's say if I start with B this time, that's a difference of 4, or that's a coordinate of 4. D is down at -5, so I'm going to subtract my -5. Again, it's got to be the absolute value of that, right? Let me move this so we can put our final answer in that last spot there. Oops. And then be careful when you're subtracting negative numbers. I'm trying here and it's not working. So if we find the difference in the distances there, we're going to have two negatives, so that's going to make a positive. So we end up really with 4 plus 5, which is going to be 9. Absolute value of 9 is still 9. So our answer here is just going to be 9. So we could say BD has a length of 9 units. Okay. Again, you could do bunny hops to check, but for right now, as long as we have a horizontal line or a vertical line, it has to be straight up and down or horizontal, then we can just find the difference in the distances and we get our final length. All right, so not so bad. So how do we find the length then of AB? Well, AB, if we were going to draw that segment in there, that's no longer going to be horizontal or vertical. It's a slant. And we can't count slants on a coordinate plane. It doesn't make sense to try to do a bunny hop because you're not really going a full length. You're not really going a full length. Like this would just be a very rough approximate. So we need to come up with some sort of a formula so that we can figure out, well, how would you get the length of that segment? So that's when our distance formula comes in. And it's generally the same concept as the absolute value of the difference. It just looks slightly different. So say we take the same segments, same points that we had before. A is still at negative 3 comma 0, B is still at 0 comma 4. And we would use the distance formula, which is written out here. It looks funky, I know. I explain it in 1 second. We can go ahead and find the length of that segment. So the way that we use our formula, we have to find the distance between two coordinates. So our first coordinate, we can write that out as an x1 value and a y1 value. So we all know our x coordinate goes first and our y coordinate goes second. Just because that's the first coordinate we're using, and it doesn't matter which one you count as first, I'm just going to put a little subscript. It's it's like the opposite of an exponent. It's below. So it's just a teeny tiny little one there just to signify that, hey, that's my first coordinates, x value and y value. If we turn down next to our second point, B, that again is going to have an x value and a y value, but we're going to call B our second coordinate. So we're going to call this x2 and y2. Again, just signifying that that's our second coordinates, x value and y value. So from here, let's plug into the formula. Again, it looks really scary, but it's not too bad. The more we do it, the easier it's going to get. So D represents distance. So the distance is equal to the square root of the difference in the x values. So 0 minus negative 3 squared plus the difference in the y values squared. So our y value, it was y2 minus y1, and again, squared. All right, so let's go ahead. According to our order of operations, in order to simplify this, we're going to have to do what's inside the parentheses first. So 0 minus negative 3 is going to give me 3. And 4 minus 0 is 4. Exponents is going to come next. 3 squared is going to give us 9. 4 squared will give us 16. 9 plus 16 is 25. And the square root of 25 is 5. So we can say that the distance between point A and point B here, or the length of that segment AB, is 5 units long. Not too bad, right? You're just finding the difference in the x values, square it, difference in the y values, square it, add those together, and finally take the square root. So it's a couple of steps, but not too bad. So take a minute. It's now your turn. So let's find the length of CD. I'll scroll back up so that you guys can see it. So I would pause the video, try to do the exact same formula that we just did, and see if you can figure out the length of CD. When you're ready to check your answer, go ahead and hit play. All right, so for CD, let's write out the coordinates first. So C is located at 4 comma 0, and D is located at 0 comma negative 5. I like to write out the coordinates first. That way I can put my little notations over those coordinates so I know specifically what's my x1, y1, and what number represents my x2 and y2. So 4 will be my x1, 0 will be y1. We have 0, this other one here will be my x2, and negative 5 will be my y2. All right, so from here, whenever we do anything in this class in geometry that has to do with a formula, I definitely recommend writing out the formula first and then showing me what you're plugging in where. That way I know from grading, for a grading purpose, I know what formula is you're trying to use. So that's some points. And you're showing me what you know to plug in where. So everything is just to try to maximize points. So I'm writing out the formula. Distance is the square root of x2 minus x1 squared plus y2 x2 minus y1 squared. A little longer. And now fill it in. My x2 is 0. My x1 is 4. My y2 is negative 5. My y1 is 0. Again, square it. So I'm going to simplify my parentheses first. 0 minus negative 4 is negative 4. I gotta square that. Negative 5 minus 0 is going to give me negative 5. Square it. Remember, whenever you square a negative number, the answer is always going to be positive, because to square negative 4 means you're doing negative 4 times negative 4. So a negative times a negative is always going to give you a positive answer. So if I square negative 4, I get 16. If I square, plus sign. If I square 5, I end up with 25. Add those together, and I get 41. All right, so a couple different things that we can do from here. A, I am totally okay with you just telling me that CD has a length of the square root of 41 units, because that is the most precise answer possible. If you plug that into a calculator, you get a decimal approximate. It's not going to be a precise answer. So the most precise answer possible that you can give me is just a square root of 41. Okay? If you choose to plug it into the calculator, you get 6 point something. That works too. All right, just to plug it in the calculator, just so that we're on the same page, square root of 41, your square root button is up above your square key, so you have to hit second, first, and then the square key. That gets you a square root. You type in 41, hit enter, and then there's your decimal approximate. All right, if you are going to prefer this method, that's fine. Just make sure you round it to the nearest hundredths place. So in our case, it'd be about 6.40. So we can say CD is approximately, we got to use the right symbol, 6 point, and I forgot it already, 6.40. All right, so again, I'd prefer the precise answer, leave it as a radical, plus it's less work, right? Why are we going to go make stuff harder? But all right, so that was fun and it wasn't too bad, but do you want to know a shortcut? Back in middle school, you guys already learned the distance formula and you didn't even know it because you called it by a different name. So let's say now, instead of, I just switched up some of our segments. So let's say that we wanted to find the length of BC. Well, in our distance formula, it told us that we had to find the difference in the x values and then a difference in the y values. So if we find a difference in the x values, so x goes this way, right? X to x. If we want to find this length here, the difference in that length, difference in those points is going to be 4 units. If I try to find the difference in the y values, well, that's asking really what's the length from here to here, in which case that's going to be also 4 units. So don't you remember the name of some formula? If you notice a triangle that I just formed, if you know the length of 2 sides of a right triangle, what formula helps you to figure out the length of the third side? If anybody was able to come up with Pythagorean theorem, very, very proud of you. Pythagorean theorem, a squared plus b squared equals c squared, where a squared and b squared represents the length of the 2 sides or legs of the triangle, and c is going to represent the hypotenuse. So for us, a is 4 and b is 4. C is actually going to be what we're looking for. All right, so let's plug into the formula. A squared plus b squared equals c squared. 4 squared, 16. 4 squared is 16. 16 and 16 make 32. And the last part, in order to solve for c, The opposite of squaring something is taking the square root. So C is going to be equal to the square root of 32 units. Again, yes, you could plug into the calculator if you would like to, get your decimal approximate, 5 point something, but we don't need to. I'm totally happy with you guys just leaving it this way. So I am going to tweak, though, the answer. Instead of just saying C, the question's really looking for the length of BC. So I'm just going to say that BC, there we go, is equal to square root of 32 units. All right. So shortcut, I think so, right? A little less steps, easier formula. You guys probably already know that formula. So feel free to use the Pythagorean theorem as an alternative to using the distance formula. All right. Why don't you guys go ahead, pause the video from here. Let's change the directions. I just found BC for you. So why don't you please try to find the length of AD. So for AD here, we again want to find the difference in the x values, which it looks like that's 3 units. We want to find the difference in the y values. So 1, 2, 3, 4, 5 units there. So if we're going to plug these points in, or lengths, into the Pythagorean theorem, I end up with 3 squared plus 5 squared equals c squared. So 3 squared is 9. 5 squared is 25. Add them together for 34.
34 comes to 34.
And then the last piece we need to, in order to solve for c, is take the square root of both sides. And therefore, we can say that AD is equal to the square root of 34 units. Not too bad, right? So now you know 2 different ways, whether it's distance formula or Pythagorean theorem, you know 2 different ways to find the length of a segment on a coordinate plane. So make sure, if you're good with this video, that you go ahead and take a look at the next one, which is going to be how do you find the midpoint now of a segment. Thanks for watching.